Thank you, thank you. Hello and good afternoon. Happy to see such a good show up here. For this lightning talk, we're going to do some time traveling. We're going to go back in time to the early days of CI/CD tooling and the build environments that we take for granted today. We'll look at the good things and also the less good things of those environments. But to start off with and set the scene, my name is Anders Hammar. I started out as a Java developer about 25 years ago. And after a while, I figured out that what I like more than developing is setting up good development and build environments. So I fell in love with the Maven, the Apache Maven build tool, and I also became one of the members of the Apache Maven team. And later on, I turned to CI/CD tooling, and that's what I do today. And I'm also one of the locals here in Stockholm. Okay, so the topic of today, or this lightning talk, is evolution of CI/CD environments. So I will look at one perspective. There are a number of ones, and I have to simplify a little bit as well due to the time constraint of this talk. So I will look at what I call more of the architectural aspect of build environments. But to start out, we'll look at what I see as 3 different generations of CI tooling or CI/CD tooling. And as I said, I started out almost 25 years ago. And when I started out in 2000, there was no CI tooling. So what we did is that we developed on our local computers, and we built on the computers, and we sent it off, or we just checked it in somewhere, and someone else built the application. And some of you probably recognize this, is that you could get different result, right? So I could compile on my computer, but it wouldn't compile on my colleague's computer. So this was a great thing, or a big deal, when the first CL tooling showed up. So this was somewhere around 2001, we had cruise control, and later on, in 2005, we had Hudson, which later on became Jenkins. And we also had TeamCity, and many companies that built their own solutions as well. But I call this dedicated servers. Typically, what you did is that you installed this on some leftovers that you had hanging around. So it was a physical server, you tucked it away under a desktop, and you installed this software there, which built your code continuously, right? Later on, we started to use the cloud, and we installed it on VMs in the cloud. And as that happened, many of those providers and other players, they recognized that we want to have this as a service. So we got the CI tooling as a service, and we had products like Travis CI, Circle CI, and also some of the cloud providers like AWS had the code build, etc. But this was similar to the solution we had at dedicated servers. It was just that we had it as a service. Today, what many of us use is what I call integrated solutions. So GitHub Actions is probably the most known one. You get it together or integrated with Git, for example. And also, if you using something like OpenShift, you can have it integrated into your platform as OpenShift pipelines. We also have GitLab CI, which I think was the first player in this field in 2016, and there's Bitbucket pipelines, etc., etc. Okay, so these are the 3 different generations as I see it. And when we look at these, I'll try to map this to the actual solution of the build environment. So the actual environment where we built the code, right? So the first one I call just a build server. So this is what we did in the beginning, the first generation with dedicated servers. We had a single server for all builds. So it was a shared build environment, just one single server. And if you look at the pros and cons with this, or before I do that, just want to be fair and say that when we got this, it was revolutionary. Because before that, we had nothing at all. As I said, the result could depend on the local computer, if it worked or not. So But as a matter of fact, and we put today's glasses on, there isn't really anything good about this. In the early days, it was easy to set up, so that was good, but today, this is not anything I'd recommend anyone to go with. So we have a bunch of cons or bad things about this. One of them being you have a limited resources, right? You have just one server, you can't grow anything beyond that. Also, you're stuck with that OS that your server is on. So if you have a Windows build server, you're stuck with the Windows platform. Also, which I think is even worse, is that you have low or no build isolation. So one build could affect another build. And also, as everything is hosted on one server, the CI service itself is on the same service. So if you have a build going rogue, it will probably kill the service altogether. Okay, so to address most of this, if not all of them, we started to add what I call shared workers. So we scale this horizontally, we add more servers, which would take care of the builds. So they are still reused build environments, but they are separated from the CI service itself. And we can see that we have two different flavors of this. One of them being the static pool, which is a pre-sized pool. This would typically be if you own your own hardware, because it doesn't really matter if you shrink or grow the pool. The other flavor would be the dynamic pool, which you'll grow if you need more power, or you shrink it when you don't. So this is probably what you would have if you using the cloud, when you pay per the minute, right? So this solution has lots of benefits. So what it does, it enables you to have different OSs. So you can add Windows workers, you could have some Linux workers, etc. You could even have Mac OS workers. And as these workers are reuse environments, they're already up and running. So you have no startup time. And also, you typically have tooling pre-installed. So that would mean that everything is set up for your build and will be ready to go. Also, if you go with the static pool, it's fairly easy to set this up. If you go with the dynamic pool, maybe a little bit more work. However, if you go with the dynamic pool solution or the flavor, it's easy to scale out and in. However, you still don't have great build isolation. As the build environments are reused, one build could affect the next build on the same worker or the same server. Also, one of the drawbacks is, as the idea is that the tooling is pre-installed. So when you're hacking along, you want to try a new tooling, and you figure out or find out that it's not on the workers yet, you probably need to file a ticket with the admins to have them install this tooling. And it's going to happen in a day or two or even longer. So then you have to wait, and you lose the momentum. And also, however, this could be managed in different ways, but the workers tend to diverge over time. So the builds could affect the profile of the user account performing the builds, etc. Okay, so when we come to these solutions as a service, those are typically multi-tenant. So driven by those services, we had to come up with a better solution for this, where we have the build environment or a new build environment for every build. So this is what I call the VM-based workers. So basically what it is, that the CI service would set up a new, fresh build environment dynamically for every build. So it's based on a VM image, which is battle-tested and as a proven solution to have or use in a multi-tenant environment. And the idea here is, most often at least, that you get a basic image. Maybe you could have Java installed, something like that, but just the basics, and then you install the tooling you need yourself in the build, which is both good and bad. And I'll come back to that. Okay, so the pros and cons with this VM-based workers solution, the good things about it is you get great build isolations. As I said, it's battle-tested. You really get a fresh and new environment. You can be absolutely sure that the build before you hasn't affected this or your environment. And also, as it is based on VMs, it's a very familiar environment for most of us. We're used to this. We're using VMs daily, maybe even for our local development environments. And you can also support multiple build OSs. You're probably limited to a few of them, not all of them, but you can choose. If you want to have Windows 1, you probably can get that. If you want to have Ubuntu 1, you'll get that, right? And which many people like is that you install the tooling yourself. So there is no need for you to file a ticket for the admins to install the tooling you need, but you control that yourself through a package manager or something else. However, with this solution, you're going to get some startup time, at least if you compare to the solution where you have the reused environments. And also, the installation of the tooling itself will add time to your builds. So it might not add that much, you think, but let's say you install some tooling and you're going to add 10 or 20 seconds, and that's going to be added to each and every build that you do or perform, right? So I believe it was Circle CI who first came up with this, that you base your and build environment or your workers on containers. So this is what I call container-based workers. And I'd like to stress out for this, and even the VM-based one, is even though it was driven by the second and third generations of CI/CD tooling, you can still get this or use this on a first generation, the dedicated servers, etc. It might be a little bit more work, but you can do that. So the container-based workers is similar to what you have with the VM-based workers, but they are based on container images instead, right? So, and the key difference here, from what I see, is that you have tooling pre-installed in that environment, because you're going to choose the container image that has the tooling you're going to need in the build, and you can probably use different container images or containers during the build time. So if you look at the pros and cons, the pros is going to be very similar to the VM-based one. You're going to get very good build isolation. Depending on the solution, how you set this up, you're going to get great or great-ish isolation between your builds. However, you're going to get very fast startup. So this tends to be faster than VM solution, and it's also very easy to use different OSs. So you're just going to pick the container image that has the, whatever. If you want to use Alpine, you're going to pick one of those. If you want to use some other flavor of Linux, you're going to pick an image that has that. And it's also possible to customize this. So if you want to add something or you want to tweak something like in an existing container image, you're going to do that, you build your own image, and you push it to your internal registry. And then you can use that in your pipelines, right? However, from my own experience, is the drawback of this, or the flip side of this, is that not everyone is familiar, or at least, or very familiar with the container world, so to say. And there are small differences or other things to think about when you use containers compared to using VM images. And I also see that I have sometimes, so if I put my security hat on, I say one of the biggest one is the supply chain security issue. Because there's a jungle out there with which images to use. You have Docker Hub, you have a number of different registries. So I'd say the flip side of this is not everyone is aware of this, and it could cause issues. OK, that's all for me. Thank you. Appreciate your time here. And if you have any questions or you want to discuss this further, you can reach me on one of these email addresses. Thank you.